Welcome, ladies and gentlemen, to the second panel of our conference, looking at the post-war operational design and policy. So let me welcome our first speaker, who is Paul Stoddart. Paul is an operational analyst for the RAF, a fellow of the Royal Aeronautical Society, and the member of the Society's Air Power Group Committee. And today, Paul will talk about the RAF bomber projects between the years 1945 and 1949.
Good morning or good afternoon, depending on where you are in the world. Researching the subject of RAF bomber policy from 1945 to 49 has been very interesting, and I hope that I will be able to do this subject justice and get across some of the issues, choices, and implications involved. Of course, the various issues, choices, and implications were not neatly bounded within that 5-year period, but I'll try not to stray too far outside it. The term bomber is generally thought to refer to large, long-range aircraft with heavy bomb loads, such as the Lancaster and Vulcan. I'll cover aircraft of that type, but I'll also consider smaller, lighter types that are often called attack aircraft or categorized as tactical, so implying that heavy bombers have a strategic role. These days, the two categories are rather blurred, given that very heavy bombers, such as the Boeing B-52, have been routinely used in that very tactical role of close air support, while so-called tactical aircraft have arguably achieved strategic results in some cases. However, in the era covered by this conference, the distinction between tactical and strategic was rather clearer. 1945 saw the development of the requirements and specifications that were to lead to the RAF's V bombers, the Vickers Valiant, Avro Vulcan and Handley Page Victor, which all first flew and then entered service between the early and mid-1950s. Though that is outside the conference period, the early programme to define and procure them is not. The V-bomber performance requirement was very advanced and technologically very challenging. This resulted in a degree of caution tempering ambition, and the RAF taking out an insurance policy of some less demanding designs. However, that led to considerable extra costs with two separate insurance policy projects, such that eventually 5 different V-bombers were built and flown within a few years, and with 3 of them entering service and serving concurrently for more than a few years. As well as the exploitation of new technologies such as jet engines and swept wings, there were also technological opportunities that were not taken up, namely the use of turboprop forms of gas turbine engines in combat aircraft and the use of a particular turbocharged diesel engine project. In 1945, the Royal Air Force and the then United States Army Air Force fielded very large numbers of heavy bombers, each powered with 4 piston engines. The RAF had over 1,000 Avro Lancasters, as well as Handley Page Halifaxes, plus many medium bombers. The jet engine was revolutionary and offered power and performance levels beyond that achievable with piston engines in terms of speed and altitude. Nuclear weapons had the potential to transform warfare and deterrence, with a single aircraft now potentially capable of causing the level of destruction previously reserved to mass raids by many hundreds of aircraft. Despite the rigours of the war years and the prospect of austerity, Britain had many strengths in aviation terms. We had built some excellent aircraft, as well as a few clunkers, with the Lancaster, Spitfire and Mosquito as the obvious examples of the former. Rolls-Royce and Bristol were the leading piston engine builders, with the Rolls Merlin and Griffon inline V12s and Bristol's Hercules and Centaurus radials. There were other notable companies, though a lack of time precludes any detail. The RAF was operating one of the first jet fighters, the Gloucester Meteor, and the nation had a world lead in jet engine development. Political plans were perhaps based more on optimism than rigorous analysis, and a major assumption was that there would be no major war for 10 years. Of course, the Korean War broke out only 5 years later. In bomber development, the focus was on the V-force for the carriage of the UK's planned nuclear deterrent. This required a huge performance increase over the Lancaster generation. It involved skipping a generation in bomber development. Instead, the RAF and the Air Ministry opted to go straight into swept-wing jet-powered heavy bombers, despite all their unknown aspects. Variations on the Lancaster theme served in the interim. Concurrently, a light bomber requirement was identified for a Mosquito successor, and that resulted in the excellent and highly successful Canberra. As for Britain's world lead in jet engines, here is perhaps the leading example of that capability from the time. This is the Rolls-Royce Nene axial gas turbine. It was first run in October 1944, and with a thrust of around 5,000 pounds, it was the most powerful engine of that time. Surprisingly, it never saw service with an RAF combat aircraft. Its only use in that sense was rather belatedly in the Royal Navy's Hawker Seahawk. The basic aircraft first flew in September 1947, but the Seahawk did not enter service with the Fleet Air Arm until March 1953. This slow pace was not atypical of post-war British military aircraft development. Turning to the turboprop variation of the gas turbine engine, the UK was well advanced in this area as well. The Rolls-Royce Dart was a leading design. First run in 1946, the early versions produced around 1,600 shaft horsepower. Despite it being an early example of a new technology, its potential was clear from the start. For example, its power-to-weight ratio was around 30% better than of a Rolls-Royce Series 61 Merlin, which was of equal power. Nor was the Dart the only top turboprop engine under development in the UK. Despite its potential, the Dart did not see service with the British combat aircraft. It had wide civilian success, starting with the Vickers Viscount airliner, powering it on its first flight in July 1948. There was early experimental use of the turboprop with combat aircraft. This is the Gloucester Meteor with the Rolls-Royce Trent turboprop. The Trent was first run in June 1944, and the turboprop Meteor first flew in September 1945. Though this proved the viability of the turboprop, it was barely exploited at all in British military aircraft. In fact, the only case of turboprop use I know of in British combat aircraft was the Westland Wyvern Strike Fighter. I emphasise the strike element of its role to justify including it in this bomber-focused lecture. The Wyvern used the Armstrong Siddeley Python, which produced just over 4,000 horsepower. This was considerably more than the early versions of the Dart. Thus, the Python had potential in a 2 or 4 engine layout as the power plant for bomber aircraft. However, it was never used in this form. Moving definitely into the bomber aircraft category, it was the Soviet Union that exploited the turboprop for such types. This is the Tupolev Tu-95 Bear, a very long-range bomber indeed. First flown in 1952, it entered service in 1956 and is expected to serve until at least 2040. The RAF focus, meantime, was on the pure jet engine B bombers, and the turboprop option was not seriously considered. An alternative power plant design of the late 1940s was the turbocharged diesel engine. This concept offered very good fuel economy, which is particularly useful for aircraft requiring long endurance, such as in maritime patrol. The Avro Shackleton was designed for this role and entered service in April 1951. A version, the Shackleton Mark IV, was intended to use a turbocharged diesel, the Napier Nomad, but the Mark IV was cancelled and the Nomad itself was not continued. Napier was a company seemingly addicted to complexity. It spent the war on its 24-cylinder Sabre piston engine for the Hawker Typhoon and Tempest, but turned to turbo diesels for low fuel consumption. The Napier Nomad was first run in October 1949. The first version was almost unbelievably complex, as the cutaway suggests. The second was simpler, relatively speaking, but also significantly lighter, though still a bit of a lump. It also featured a world-class level of efficiency with an outstandingly low specific fuel consumption. It should be remembered that the issue for long endurance is not just the weight of the engine, it is the weight of the engine and the fuel load for a given mission. The rate of combat aircraft entering service was unsurprisingly high during World War II, but then declined dramatically for the rest of the decade. 1946 saw 3 types enter service, all 3 having obviously been developed while the war was still running. The de Havilland Vampire Fighter, the 2 tactical types with attack capability, de Havilland's Hornet and the Bristol Brigand. There was then a long gap until the Boeing B-29 Superfortress entered service with the RAF in 1950, known as the Washington. The next British-built combat aircraft did not start RAF service until 1951 with the Canberra. Slow development can lead to failure. The Bristol Buckingham medium bomber was developed to a 1941 specification, but after slow progress turned out to be an OBE aircraft. OBE as in overtaken by events. Practically anything it could do could be done better by the superlative Mosquito, which was already in service. The Buckingham bomber was cancelled in August 1944. The armed medium bomber was obsolete. Speed and altitude performance were now the driving factors in design. Thus, in 1945 and beyond, we have the following tactical aircraft types in RAF service. The de Havilland Mosquito, an outstanding design and perhaps the best British combat aircraft of World War II, whose success directly led to the parallel development of a jet-powered light bomber alongside the priority V-bomber program. The Hornet and the Brigand. Compared to the 7,000 plus Mosquitoes built, the Hornet and Brigand were produced in very limited numbers. The Mosquito continued in the front line and was replaced in the light bomber role from 1951. The Hornet was a sports Mosquito, described as two Merlins hotly pursued by an airframe. Designed originally as a long-range fighter, it saw use in the attack role, serving until 1956. Whereas the Hornet was sleek and beautiful, the Bristol Brigand was not. The Brigand was derived from the Buckingham, trying to get something from the money expended. It served briefly as a torpedo bomber with Coastal Command, and then took on the light bomber role from early 1949. It was used in the ground attack role in the Malayan counterinsurgency campaign from 1950 to 1954. Neither the Brigand nor the Hornet was used in the Korean War, where they could have had a role in the extensive interdiction campaign against the Communist forces' lines of supply. Arguably, both aircraft could have benefited from being fitted with turboprop engines in place of their piston engines. The English electric Canberra was an outstanding and long-lived design arising from a far-sighted wartime requirement. In 1944, a jet-powered successor requirement to the Mosquito was decided on, and the specification was issued in early 1945. The Canberra was to use the Rolls-Royce Avon, an axial-flow jet engine, which was first run in spring 1946. Compared to a late version Mosquito bomber, the B Mark 16, the Canberra was 40% faster, had a 30% higher ceiling, and a 50% greater internal bomb load. And remember that the Mosquito had excellent performance for its time. This demonstrates the step-change in performance achievable through exploiting jet engine technology. The inherent rightness of the Canberra's specification and design are clear given its very long service following its first flight in 1949. 55 years in RAF service says a lot. The rate of development is dependent on resources. A near Canberra contemporary was the North American B-45 Tornado. It first flew in March 1947 and entered service 1 year and 1 month later in April 1948. The Canberra took almost twice as long between first flight and service entry, May 1949, May 1951, despite being an aircraft of similar complexity to the B-45. Whereas the B-45 served for only 11 years in the United States Air Force, the Canberra in its B-57 version, built by the Martin Company, served in the USAF from 1954 to 1983, including ISR and interdiction roles in the Vietnam War. That the USAF bought a British design over the various American rivals says it all about the Canberra's quality. Moving on to the heavy bombers, finally. The Tizard report of July 1945 set the policy direction for RAF bomber use immediately after World War II. The tactic of mass raids with 4-engine bombers was to be continued, while the V-bombers and the nuclear deterrent were developed. Essentially, this saw the continuation of the Lancaster in various forms, though in considerably lower number than the Lancaster itself was procured during World War II. It's worth remembering that the heavy bomber, forming the core of Bomber Command into the 1950s and into the V-Force, derived from a 1936 specification which gave rise to the Avro Manchester. In turn, the Lancaster, a Manchester with 4 Merlins, first flew in January 1941, and by 1945 is equipped 56 squadrons in Bomber Command. The Avro Lincoln was a Lancaster derivative based on a 1943 specification and entering service in August 1945. The Lincoln was not a huge advance on the Lancaster in performance terms. The subsequent Shackleton was a more extensive development, and it entered service with Coastal Command in 1951. It was a prime contender for turbo diesel or turboprop power, but the option was not followed, and the Shackleton eventually served until 1991 with its 4 Rolls-Royce Griffon piston engines, burning high-octane aviation spirit, making for a very noisy aircraft for the crew. While Avro were busy with the Lancaster and Lincoln, Vickers was working on a heavy bomber successor to the Wellington and Warwick in the form of the Windsor. This was the final design by Barnes-Wallis using geodetic construction. It did not offer a significant increase in performance over the Lancaster and was not adopted. As with the post-war attack aircraft, the heavy bombers were procured in relatively small numbers. In 1950, there were 21 Lincoln squadrons in Bomber Command. And as said sooner, the B-29 Washington, the Superfortress, was procured in small numbers on loan. Now, the Windsor was a large aircraft, though several British companies were planning far larger bombers to succeed the Lancaster. The Vickers Scheme C design shown here is an example of the 75-ton bomber concept that was raised in late 1942 and prompted a range of designs from several companies. The Scheme C had a wingspan of around 210 feet, or twice that of a Lancaster, as well as 6 engines. These were piston engines. You'll note that despite the rather unconventional canard design, it has a straight wing and multiple turrets for self-defense. The 75-ton bomber concept had some potential to bridge the gap between the Lancaster generation and the V-bombers by offering greater range in the meantime. The Convair B-36 Peacemaker showed how that concept might have been realised. The B-36 first flew in August 1946 and entered service in 1948. It had a span of 230 feet. Given its size, one pilot said it was like sitting on your porch and flying your house. The B-36 had a massive range, well beyond that achievable from any possible development of the Lancaster. With a combat radius of 4,000 miles, carrying a very heavy bomb load, it was a generation beyond World War II designs and was capable of cruising at over 40,000 feet. It is noticeable, however, that its main power plants were 6 radial piston engines, although later versions gained 4 jet engines for improved takeoff performance and dash speed over the target. A turboprop version would have been interesting. And to give you an idea of just how big the B-36 was, here is a B-29, the biggest World War II era bomber, alongside a P-51 Mustang. And here is a B-29 with a B-36. And on to the V-bombers themselves. Operational requirement 229 required the capability to carry a 10,000-pound load from the UK to Moscow. Eventually, within a 3-year period, 5 different prototypes were to fly, and those were from 4 different companies. The 1946 OR-229 required a turbojet aircraft capable of high speed and high altitude with no defensive weapons. This was the Mosquito concept adopted by the heavy bomber world. 2 very advanced design proposals were selected, the Avro Vulcan and Handley Page Victor. Given the technical risks, a low-risk option, the Sperrin from the Short Brothers Company, was also adopted, and then a medium-risk design as well, the Vickers Valiant. Thus we had 2 competing main designs and 2 insurance policies. Nothing like this was done for the Canberra, nor would there have been the money or the industrial capacity to do so. The Vulcan and Victor were solutions to specification B-35-46, which was issued in early 1947. It required a cruising speed of 500 knots, 575 miles an hour, and a service ceiling of 50,000 to 55,000 feet, way beyond Lancaster capability. The 10,000-pound payload was one element of the specification, along with the capacity to carry a bomb that was some 30 feet long and 10 feet in diameter, the first British nuclear weapon. This was a very, very demanding requirement. The specification stated that a V-bomber was to have at least twice the speed and twice the over-target height of the then Curragh bomber force. Much greater range and ideally a larger bomb load. And then the insurance policies were drawn up. Specification B-14 and 46 required a lower speed, 435 knots, and a ceiling of 35,000 to 45,000 feet over target. It was issued in August 1944. It was to be a simple aircraft capable of carrying a 10,000-pound load to a target some 1,500 nautical miles away. It's been described as essentially little more than a traditional aircraft fitted with jet engines. And here we have the short Sperrin, which was meant to meet the specification B-14 of 46. Very conventional design with a straight wing. It looks rather similar to a camber in general arrangement, though perhaps a camber on lockdown, not enough exercise, and too many takeaways. The Vickers proposal for the V-bomber requirement was originally rejected on the grounds that it had lower performance than the preferred choices of the Vulcan and the Victor. Following lobbying by Vickers of the Air Ministry, the Valiant was then reinstated on the grounds that it was of lower risk due to its lower performance. Specification B9 of 48 was written around the Valiant design, and it made its first flight in May 1951, some 27 months after contract issue. Meanwhile, in America, resources in developing jet-powered heavy bombers were rather more focused. After the Convair B-36 Peacemaker, the next USAF bomber was the Purejet Boeing B-47 Stratojet. It first flew in December 1947 and was introduced into service only 3.5 years later in June 1951. It had a very similar performance to the Vickers Valiant, yet more than 1,000 B-47s had been built before either the Vulcan or the Victor were cleared for service. Thus, the post-war bomber procurement policy was to produce one light bomber design, the Canberra, but also there were 5 V-bomber designs built and flown, with 3 of them serving concurrently in the RAF for some years, the Valiant, Vulcan and Victor. The post-World War II period saw great ambition in bomber development with the inception of the V-Force and the Canberra. The extent of the insurance policy designs for the V-bombers was excessive. Scarce resources were spread too widely, so slowing the potential rate of progress. It's notable that in the programme for the 1949 SBAC air show was the following statement: pure jet engines, swept-back wings, the possibility of supersonic speed, and the achievement of high-altitude flight over great ranges are all unknown quantities. Yet at that time, supersonic flight was then commonplace in the USA. The F-86 Sabre and the MiG-15 were in squadron service, and the B-47 swept-wing bomber was in large-scale production. The slow progress in Britain is exemplified by specification B-35 and 46, which led to the Victor and the Vulcan. In 1947, the Air Staff thought it would take 7 years. In fact, it took 9 years and 8 months for the Vulcan to reach a squadron, nearly a 40% overrun in time. The aviation writer Bill Gunston commented on the V-bomber program in that ordering the Sperrin, Valiant, Vulcan and Victor, the Air Staff and Ministry of Supply were, quote, guilty of a gross error of judgment. He considered that the overinsured policy threw away any possibility of parity in timing with the US, such as the Valiant perhaps shortly following the B-47 Stratojet into service. In short, Britain built some very capable bomber aircraft after World War II, but progress was slow, owing to a shortage of resources and, perhaps more importantly, the excessive spending on different types in the V-Force program.